Hello friends, this is Praveen. Welcome to online course on Python basics. Today we will see how to print a Fibonacci series and then we'll print diamond shape using numbers. So what is a Fibonacci series? It is a sequence of numbers starting with 0 and 1 and then the following numbers are the sum of the preceding two numbers. So what does it mean? 0, okay, wait, here, we'll start here. 0 and 1. This first two numbers are fixed and then the next numbers will be the sum of the previous two numbers. So 0 and 1 is 1, then 1 plus 1 is 2, then 2 plus 1 is 3, then 3 plus 2 is 5, then 5 plus 3 is 8, then 8 plus 5 is 13, then 13 plus 8 is 21, then 21 plus 13 is 34, and so on. We can increase endlessly. So why this Fibonacci series is significant to us? The Fibonacci sequence is significant because the ratios between the two certain numbers in the sequence, which is 0.236, 0.382, 0.618, 1.618, 2.618, and 4.236 approximately, ignoring the first few numbers. So what does it mean? 0.236, if you check the ratio here, I'm just using the sprint. So 0.236, suppose 21, or rather, we will use the lower number first. 5 divided by 21. So this series and just third previous. So this is first, second, third, fourth, fifth, sixth, seventh, eighth, ninth. Ninth term and then eighth, seventh, and then sixth. Ninth and sixth. It will come about 0.236, not exactly, but approximate. And what we if we reverse the ratio, inverse the ratio, then it will come about 4.236. So thus we'll just change the ratio. So 5, so it will come around 4.236. And then if we change it to, suppose they just increase the number from 6th to 7th and 9th. So 8 divided by 21. The moment we do it, the ratio will approximate to 0.382. 0.382. And if we inverse it, then the ratio will come approximate to 2.618. So this is 21, then 8. So 2.618 approximate, not exact. And then the last one, the between the two numbers 21 and 13, and then 13 to 21. So 13 divided by 21. So it will come to 0.618 approximately. And if we inverse this ratio, then it will come about 1.618. So these ratios are used in financial trading, where traders believe that Fibonacci ratios gives a clue as to where the given financial market will move. We won't go into details about that. We'll concentrate on Python part only. And the next, this 0.618 and 1.618 are called golden ratio because this can be used in describing number of veins in a leaf or to describe magnetic resonance of a spins in cobalt niobate crystals. So let us start our Python coding. So what we'll do, we'll start with the asking with the input from the user that how many terms he wants to print in the Fibonacci series. So num terms, sorry, num terms is equal to int, because it has to be an integer data input, and then we'll use the masses, number of terms. That's it. Then the first two terms are fixed. So x1 comma x2 is equal to 0 first term and then 1. So two terms are fixed. Then we will declare another variable count is equal to 0, which we will check with num terms. Now if num terms is less than 0 or equal to 0, what do we want to print? We want to print a masses. Please enter a positive number. Please enter a positive. But what if the num terms is 1? So then if elif will use num terms is equal to 1. In this case, what we will do, we'll simply print the first term in the Fibonacci series, and we know this is x1 0. So we'll just give print Fibonacci series up to up to this up to this terms, and then the value for this placeholder format will pass this num terms. That's it. And then I'm just copying it because it will use this line again, and then we'll print the first term, print x1. Now else, if the number is greater than 1, or if the user wants to print a Fibonacci series of greater than 1, so else, just use this control V, print it. Just come back to this part, enter, and then now we'll use a loop that will check if the we have printed Fibonacci series till num terms. So while count is less than num terms. So why it is less than? Because we are starting from count 0. So just one less than will make the number of terms equal to num terms. So first we'll print n1, the first term, print x1 rather, x1, and then the xth term. So xth term or xnth term is equal to x1 plus x2. So this will become, and then we will update, because this xnth term will be the sum of the two terms, and right now it is will be the sum of this 0 and 1, the second term. But what we are trying to do, we will just update these values with this new x1 and x2. So x1 will become now After adding this, x1 will become x2, and then the x2 will become xnth, xnth, and then we will increase this, sorry, then we will increase the value of the count by 1. So what will happen if we take 2, if the user inputs 2, then it will print first 0, then the xnth term will become 0 plus 1 is 1, and then x1 will become x2. So this x1 will become 1 and x2 will become 1 as well. In the second case, it will print again x1. So x1 is 1, it will print 1, and so it is printing 0 and 1. Now in the next series, next term, if we want to print 3 terms, then what will happen? This xnth will become x1 plus x2. So x1 is 1, x2 is also 1, so xnth will become 2, and then x1 will become x2, so it will become 1, and then x2 will become xnth. So what will happen this time? It will again print 1, because the third number has to be 1, 0 plus 1. But this time x2 has become 2 now. So let us take it here first. So number of terms, suppose we want to print 6 terms. So 0, 1, 1, 2, 3, 5. So first two terms 0 and 1, then the sum of these two terms is 1, then sum of these two terms previous two digits is 2, then sum of previous two digits is 2 plus 1 3, then sum of previous two digits 3 plus 2 is 5, and so on. So I'm just executing one more time. So I'm using giving 8. So this time 0 1 1, then 1 plus 1 is 2, then 1 plus 2 is 3, 2 plus 3 is 5, then 5 plus 3 is 8, then 8 plus 5 is 13, and so on. We can continue printing like this. So I'm just executing one more time. So this time I'm adding 12. So you can see 8 plus 13 21, 21 plus 13 34, 34 plus 21 is 55, then 34 plus 55 is 89, and so on. We can keep on printing the number of terms as we want. So next we will see about diamond shape. So this is about Fibonacci series. I'm just commenting here, making a comment, printing a Fibonacci series. Next, so diamond series. So how it diamond shape using numbers. So how it looks like. So we will see here in this. This is the diamond shape we want to print. The 1, then it will again start 1 2 1, then 1 2 3 2 1, 1 2 3 4 3 2 1. So what is happening here, in the diagonal part of the diamond, the numbers are increasing from 1 to 7, and then it is further decreasing, and 1 to 7 and further decreasing, and then the further the numbers are getting decreasing one by one. So what we can do, we'll have two part. First we'll print this top part, and then the bottom part. And in the top part itself, we have three sections. First, we have to print the space, needed space from here to here. Then we need to print the forward slash 1 1 2 1 2 3 1 2 3 4 1 2 3 4 5 1 2 3 4 5 6 1 2 3 4 5 7, and then the decreasing series 1 2 1 3 2 1 4 3 2 1 5 4 3 2 1 6 5 4 3 2 1. So let us get back to our spider ID. So here, so how many numbers we want to use in the diamond set? So n is equal to int, we will use here, and is equal to int input. So numbers used in diamond set. Next, we have to print the spaces. So for, and in the first line we need more space, then second line we need one less space. So we'll use this for I in range n comma 0. We want the diagonal, in the diagonal we don't want any space to be printed, then -1, the it will decrease one by one. So now what we want to print the spaces, and how many spaces we want to print this I minus 1, because one will remain there, so just we need one less than the n space, and then we want to print this space star, so we'll multiply it and we'll give n space, and then we want all these spaces, and follow, after that we want to follow the numbers, so we'll use this and is equal to, so and is equal to the separation. We don't want to go to the next line, so this is what we want. And after that we need to print the forward counting numbers. So what we will do for j, another number j in range, and here what we need to print, in the first case 1, in the second case 1 2, and then in the third case 1 2 3, in the fourth we want to print 1 2 3 4, like that. So we will use 0 comma n minus I plus 1, n minus I plus 1. So what does it mean? Why am I choosing this range? Because when I is coming here, it is taking the value n, so n minus I, n minus n, so in the first case it will become 1, and it will loop only once, so it will print only 1. In the second case, when it comes to n minus 1, so n minus 1, so 1 plus 1, so it will loop 2 times, so it will print 1 2 and so on. That is why I'm using this, and we will use the print here, and we want to print j plus 1 here, and then again n is equal to, because we want to print the reverse reach as well, after that the decreasing numbers, and we'll give, after that just we want to check how this will look from this, so I'm just giving a print here to change the lines. So if we execute this line, so what it will print, so I'm just giving 5, so it is printing 1 1 2 1 2 3 1 2 3 4 1 2 3 4 5. So the first one quarter of the diamond it is printing. So we need the second quarter here. We need the second quarter here, so that the triangle, top triangle of the diamond will be printed. So for that, what we want, we will use another loop here for k in range, and then here we will use, we have to actually use here, we have to print the numbers in descending order. So the start number should be number n minus I plus 1. So what will happen when I will be n, it will come n minus I, n minus n plus 1, 1, then 1, then minus 1. So in the first case, we don't want to print anything. So 1 start is 1, end is 1, step is minus 1, so it won't go to in this loop. And in the second case, when the value of I is n minus 1, then n minus 1, so 2, the start will become 2, then 1, then minus 1, so it will start from 2. So it will start from 2, so we need to print 1 less than the key value. So print, because we want to print only 1 here, only 1 in the second case. So we want to print, so I am printing k minus 1, k minus 1 comma, and it's equal to, we want to print in the same line, so this one. And we'll check here, just select this line, so only these lines will be executed. So what if we want to print 6? So you can see here, the top half of the diamond is ready. 1, in the first case, it is printing 5 space, then 4 space, then 3 space, then 2 space, 1 space, 0 space. In the this loop for Z, it is printing 1 first time, the second time it is printing 1, 2, in third loop it is printing 1, 2, 3, in the fourth loop it is printing 1, 2, 3, 4, then 1, 2, 3, 4, 5, then 1, 2, 3, 4, 5, 6. In this loop, in the first time it is not printing anything. In the second time it is printing 1. In the third loop it is printing 2, 1. It is in the fourth loop it is printing 3, 2, 1. In the fifth loop it is printing 4, 3, 2, 1, and so on. So now we need to print the lower part of the diamond shape. So what we will do, we will just reverse the process. So we can just copy it. We'll copy these things. We'll just reverse it. So let us not copy, because otherwise it will become clumsy. So what we'll do here, again for I in range, and this time the step, this start should be lower 1 to n, because in the first case we need to print the one space here. It should start from here, from 2. So print I, then star, then space, and again this end, sorry, and should be the same, because we need to print rest of the numbers in the same line. Now after this, we want to print the third quarter. So we will use here print, sorry, another loop for j in range, and here we will use 0 to n minus I, and the first term First time it will print, if it comes to 1, it will print from this n minus 1 terms. So print, because we want to print from 1, so we'll use g plus 1, g plus 1, comma, and is equal to plus. And then I'm giving another print, so that after printing this, it goes to new line. And I'm just trying to print the third quarter of the diamond. 6. So this third quarter is also ready. Now we want to print the final part of the diamond shape. So just we'll add this another loop for k in range, and this time we have to use start at higher number, so n minus I, comma 1, comma minus 1, and then we will print here k minus 1. It is just the reverse of what we were doing in printing the top half of the diamond. That's it. So we can print now. So 7. This is how our diamond shape looks like. So we'll just see here this one. This is how our diamond shape is looking like. So what if we want to print another 6? So it is printing. So we have seen how to print Fibonacci series as well as diamond shape using numbers. So in my next video, I will be discussing about functions in Python. Thank you for watching the video. If you liked the video, then please like, subscribe, and share it.